Welcome, everyone. Now, if looking at a math textbook sometimes makes your heart race, I want you to go ahead and take a deep, deep breath. Today's explainer is going to make set theory feel completely natural, incredibly logical, and honestly, entirely stress-free. Believe it or not, this exact math is used everywhere in real life. Whether you're calculating a quick shopping discount, measuring land, plotting out a building design, or even just checking your monthly phone data limit. We're tackling the concepts of finite and infinite sets today, and I absolutely promise you, by the end of this, you're going to be solving these like an absolute pro.
So think about that phone data limit for a second. You know exactly how many gigabytes you have for the month, right? It's a finite, measurable amount. You can track it, and it definitely has a hard stop. But then, think about scrolling through your favorite social media feed. It kind of feels like it goes on forever, doesn't it? It just constantly refreshes with new content, endlessly. And that fundamental difference right there, things with a hard, countable limit versus things that refresh infinitely, well, that's the absolute secret to today's entire topic. Okay, let's dive into this. Here's the exact textbook page we are decoding today, section 2.8, straight out of your source material. Now, I know it might initially look like a giant wall of text and scary algebra, but I assure you it is actually incredibly friendly once you know the secret. We are going to break down this exact page so clearly that you'll literally never panic over these types of questions again. Section 1. Defining finite sets.
So, the official definition of a finite set is a set where you can express the number of elements in definite whole numbers. But let's simplify that. Think of it like a guest list for a party. If you can count the items on that list, say 1, 2, 3, 4, and you definitely reach an end and stop, it's finite. There is a clear last item, and the total is a neat whole number. Simple as that.
Let's look at how we can visualize this concept using the examples right from the text. Set A is the students of your school. Just like we talked about, you could count every student, so that's finite. Set L contains exactly 4 specific numbers, 2, 3, 5, and 7. Set W is the days of the week. There are exactly 7 days, and then boom, you stop counting. Set S represents the solutions to the equation x squared minus 16 equals 0. The key takeaway here? Whether it's the 7 specific days of the week or a short list of specific numbers, there is a clear, comforting end to the list. You count them, and you're 100% done.
Moving right along to Section 2, Grasping Infinite Sets.
Now, an infinite set is exactly what it sounds like. It's a set where it is mathematically impossible to find out the last number. The number of elements is simply not finite. You could sit there and count until the end of time, and you know what? You would still be counting.
Let's visualize these infinite sets with the source's exact examples. Set B is all even numbers. Imagine trying to count those. 2, 4, 6, 8, a million, a billion. No way. It literally never stops. Set J is all multiples of 7. Set G is the number of points on a line. Just visualize this shape for a second. A geometric, straight line stretching perfectly out into space forever. Because it never, ever stops, it's made up of endless, microscopic points. Just like you couldn't possibly find the last integer in the entire universe, you can't visually or mathematically pinpoint a final point on that line.
And this brilliantly illustrates the fundamental differences side by side. Finite sets allow you to express the elements in definite whole numbers. You count, and you finish. Infinite sets, they make it mathematically impossible to find that final last number. Once that underlying logic really clicks in your mind, the whole rest of set theory is just applying this basic rule.
All right, let's put this into practice. Section 3, step-by-step problem solving. We're going to start super easy. Here is our first example. We are given set L, which contains the numbers 2, 3, 5, and 7. Step 1, we just read the set. Step 2, we identify what we actually have here, which is a straightforward list of specific numbers. Step 3, we count them. 1, 2, 3, 4. There are exactly 4 numbers sitting right there on the page. Step 4, our conclusion. Because 4 is a definite whole number, the set is finite. Easy, right? The simplest problems really just require counting the elements you see.
Okay, let's step it up to a medium example. Now, before we even look at the algebra, picture a visual shape in your head, a graph showing a curve that crosses a horizontal line at exactly 2 distinct points. That visual pattern alone tells us right away we are looking for a limited, finite number of answers. Okay, now let's read the equation. The set contains x such that x is an element of n, which means natural numbers, and the equation x minus 1 times x minus 2 equals 0. Please don't let that notation scare you. First, identify what's being asked. We just need the numbers that make this equation equal 0. Step 3, ignore the set brackets for a second and just solve the algebra. For that equation to be 0, x can only take the values 1 or 2. Step 4. We write out our list. The set is just the numbers 1 and 2. Step 5. The conclusion. It has exactly 2 elements, so it is a finite set. Always visualize the logic, solve the math, and then look back at the set notation. All right, take a breath, because here is the hard, board exam level question. Example 13, part 2. The set contains x such that x is a natural number and x squared equals 4. Step 2, let's just solve the algebra first. If x squared equals 4, that implies x could be positive 2, or it could be negative 2. So the absolute crucial point is right here at step 3. The rule specifically says x is an element of n. It must be a natural number. Step 4 is our filter. Negative 2 is not a natural number, so we filter it out. Just throw it away. Step 5, our final list only contains the positive number 2. And finally, because it has exactly one definite element, it is finite.
Now, what's really interesting about this slide is the surprise exam trick that's going to help you solve these way faster. Always check the set conditions, like x is an element of n, first. If you spot that condition early on, you won't even waste your time calculating negative answers that you're just going to end up throwing away anyway. Spot the n, save your time, and save your grade. You are going to be the student who checks the rule.
Finally, Section 4, your exam cheat sheet.
Let's go through this quick 5-point checklist together so you can tackle your homework with zero stress. Number 1, finite simply means countable, indefinite whole numbers. Number 2, infinite means it's literally impossible to find the last number. Number 3, real-world measurable sets like your phone data or your classmates are finite. Number 4, geometric concepts like endless lines, along with infinite number patterns like all even numbers, are infinite. And number 5, our golden trick: when given a problem, visualize the logic, solve the algebra equation, and then always filter your answers by the rules, like checking if it specifically asks for natural numbers.
See, you've completely decoded the textbook. There was absolutely nothing to panic about at all. Now that you've mastered the logic of infinity and finite limits, what other quote-unquote scary math topics are you ready to conquer next? Keep that now-found confidence high, trust the logic, and I'll see you in the next explain.